Hello. Let's now consider this unit circle that we've drawn. Beautiful geometry and platonic solids aside, we still need to ask ourselves what exactly is being measured by a radian? What is that? And I want to tell you that what it represents is a piece of the circumference of the circle. That's what a radian measures. It is a piece of the circumference of the circle. And it can be rendered in many ways. It can be rendered in this 60 over 360 times pi. It can be rendered pi over 6. That's just a simplification. But what does it mean because whenever you compute these, oftentimes you come up with a decimal that has many digits after the decimal point. And what exactly is being measured? Well, let's take a look. Let's start with first principles. We know that there are 360 and the base in this 360 degree triangle. If I have 1 degree of 360, I've got 1/360th of the triangle. I keep saying triangle, of the circle. I have 1/360th of the circle with 1 degree. And the way you find out what portion of the circumference of the circle is represented by 1 degree is you say, well, 1 degree over 360. And I want us to actually compute things. So all we really need to know to compute anything, and this is pi here, we need to know pi. If I had a calculator that had pi as a function that I could, or a number that I could hit on the calculator, I wouldn't need to do this, but I know that a pi can be approximated out to a few decimal points as 3.14159. 3.14159. Now, for our purposes in doing this decimal conversion, this is all we need, 3.14159. You don't need to be any more exact than that. So let's take our 1 degree and let's find the actual decimal radian of 1 degree of arc, or one degree of the circle. So 1 degree times 2 over 360 times pi. One degree times 2 is 2 over 360 times pi. So I've got 2 over 360 times pi for 1 degree. So 1 degree equals 2 pi over 360. And we know that we can reduce 2 over 360 to 1 over 180 times pi. And what we are finding with that number, let's just go up here for a moment, for 1 degree, we are finding that 2 pi over 360 equals 1 pi, or pi, over 180. And at this point, it's important to come up with that decimal. You just need to actually turn pi into a number and then divide by 180. And you'll get the decimal version of the radian. And that decimal version of the radian will, for a circle of radius 1, okay, the radius of the unit circle is 1, we'll get a portion of the circumference, a distance measurement. So it's often not thought of. It's a distance measurement. It's some number of distance around the circle. If I were to divide 3.14159 divided by 180, I get this decimal here. So that pi divided by 180, remember this is just a number, and that number is 0.01745, and we'll just take it out to the 5th decimal place. This is the distance around the circle. And it is actually a distance measurement of the circle. So if I wanted to ask myself, let's continue on. Let's go back to our unit circle and take a look at 30 degrees, because with a bigger angle it will become more clear that what I'm measuring is if I had a little piece of string and I had that string as the circumference, representing the circumference of the circle. What I would have with the 30 degrees here is that piece of the string from here around the circle. I would have this little piece of the string represented by this arc of line here. So let's see if that plays out. Let's clear our calculator and let's take a look. 30 times 2 is 60 divided by 360 times pi. And we reduce that down to, we said that 30 times 2 is 360, or 30 times 2 is 60 divided by 360. And I was able to pull out I was able to divide out by 30 times 2 over 360 reduces down to 1 over 6. I was able to pull out a 30, in other words. 30 times 2 over 360 equals 1 over 6 times pi. So that was pi over 6. So let's see what pi over 6 is. 3.14159 divided by 6. And I get this decimal here. This equals 0.52 3, 5, 9. Okay, so that is actually a distance measurement from here along this arc to here. That's what that distance measurement is. Let's now continue. Pi over 4. 3.14159 divided by 4 equals 0.785339. Let's take pi over 3. 3.14159 divided by 3. That equals 1.0471, or 1.047. Pi over 2. 3.14159 divided by 2. That equals 1.570. 1.570. 2 pi over 3. Okay. 2 times pi, 3.14159 equals 6.28318 divided by 3. So the decimal expression of the radian for 120 degrees is 2.094. 3 pi over 4. 3 times 3.14159 equals 9.42477 divided by 4. 2.356. Let's continue on, speed it up. 5 times 3.14159 equals 15. Wait a minute, I think I put a decimal point. 5. Just make sure I didn't do this wrong. Yeah. 5 times 3.14159 divided by 6 equals 2.617. Now let's jump down here to pi. Right. Pi is 3.14159. So the radian measurement in decimals of pi is just pi. So 3.14159. I took it out to too many significant digits, but you get the point. It's pi. 7 pi over 6. 7 times 3.14159 divided by 7. This gives me 3.1. I think I did it again. 7 times 3.14159 divided by 6. 3.66518. 3.665. Okay, we'll stop with the significant digits there. And then 5 pi over 4, 5 times 3.14159 divided by 4 is 3.926. And then we'll go here to 4 pi over 3. We'll take 4 times 3.14, oops, 4 times 3.14159 divided by 3. And that equals 4.188. Let's continue. 3 pi over 2. 3 times 3.14159 divided by 2. 4.712. 4.712. So now 5 pi over 3. 5 times 3.14159 equals, divided by 3, 5.235. 5.235. 7 pi over 4. 7 times 3.14159 divided by 4 gives me 5.497. Okay? 5.497. 11 pi over 6. We're almost done. 11 times 3.14159 divided by 6 gives me the radian measurement for 330 degrees in decimals. That's 5.759. Now for 360 degrees, that was 2 pi. Well, that's just 2 times 3.1415. And that equals 6.283. So now we have each of our degrees in radians expressed both in terms of pi and then as a decimal. Now, because pi is a number, for example, 60 degrees is pi over 3. Pi divided by 3 was 1.047. What did it represent? It represented the distance from right here all the way up to this point right here, the 60-degree point. It is the portion of the circumference of the circle represented by the arc from 0 to 360. So the question is, what is the, let's say, what percent of the unit circle is represented by each of these degrees? What percent? Now, if we're thinking about that, it might be helpful to know in what terms are we talking. So let's just say, what is the equation for the circumference of a circle? If I have a circle, if I have a circle here, I know that if I have a circle, I know that this distance is the radius. That's the radius of the circle. In order to find the circumference of a circle of the radius, and in the unit circle that is equal to 1, the radius of 1, my goal is to find the total circumference of this circle. So I would take 2 times the radius, that would give me the diameter, times pi. Because pi times the diameter gives me the circumference, again, the perimeter of the circle. So what is that? Well, 2 pi r equals the total circumference of the circle. So that's 2 times pi times r. R is 1, so that's just 2 times pi. So the total radius of the circle is 2 times 3.14159. And that's equal to 6.283. So 6.283 represents 100% of the circle. And the way that we find that it represents 100% is that we divide our circumference measurement here, the radian measurement, by the total radian measurement of the circle, which in this case is 6.283. Well, that plainly equals 1. Expressed as a percent, if I had 1.00, that would represent 100% of the circle. Now that should be plainly obvious. This is the radian measurement for 360 degrees. 360 degrees, the radian measurement of 6.283 represents 100% of 360 degrees. Well, of course it does. It's the entire circumference. With a circle of radius 1, if I cut a length of string of radius 1, and I multiplied the length of that piece of string times 2, and had a longer piece of string now, and then I multiplied that piece of string times pi, I'd have a piece of string that would go all the way around the circle if you laid it out. Okay? So let's take some additional numbers and find out these degrees now as percents of the total circle. Okay, let's remember that our formula for the circumference of a circle is 2 pi r. Okay, so if the total circumference is down here, 360 degrees is 6.283, what percent of 360 degrees is represented by 30 degrees? Well, here's what we do. We have our radian measurement for 30 degrees at 0.52359. We divide this by the total circumference of the circle, 6.283. And this will give us the portion of the circle represented by 30 degrees as a circumference. This portion of the circumference represented as a percent of the total circumference of the circle. 0.52359 divided by 6.283. And what that gives me is, just write it out, what that gives me is 0.0833. If I want to express this as a percent, I can say 0.0833 is 8.33%. 8.33%. Okay, now let's keep going. Let's look at, just because I don't think most people have been taught it this way, let's just explain what I'm representing here. This bit of string of this arc right here represents 8.3% of the total string. That's what I'm claiming. Because I know if I have a piece of string of length 6.283, that represents 100% of the total string. I'm asking myself, what percent of the circumference of the circle is represented by this piece of string that's cut off by an angle of 30 degrees? If I want to cut off this little section of string right here, I've got 8.3% of the total string. Let's keep going. See if we confirm our hypothesis. 45 degrees has a portion, the circumference chunk here, the chunk of the circumference I'm measuring is 0.78539. But really, that doesn't give me much. I don't really know what that means. I'd like to express it as a percent of something. So if I say, what percent of the whole circle is represented there, I again divide by 6.283. And let's see what I get. Take 0.78539 divided by 6.283. 12.5%. That's what that is. If it's 0.125, I just move my decimal point over 2, and I've got 12.5%. Of the total circumference of the circle. The total circumference, 12.5% of the total circumference. 1.047. Divided by 6.283. what portion of the circumference of this circle, the total circumference of the circle, is represented right here by this chunk? What percent of the total circumference is represented by the chunk cut off? That chunk of arc cut off by 60 degrees. That's the question I'm asking. It's always important to ask the question out loud, because if you can actually say the question, you're on your way. So 1.047 divided by 6.283 equals 16.6% of the total circumference of the circle. Let's keep saying it in a complete sentence. Pi over 2, okay? What percent of the total circle is represented, the total circumference of this circle is represented by pi over 2? Well, we divide by 6.283. Now this is a moment of truth, because we know this. We know this because 90 degrees, if I'm thinking about a pizza, the 90-degree point cuts this pizza. I've got 4 pieces of pizza. So 1/4, if I'm thinking about the circumference, the 90-degree line, this portion is equal to 1/4 of the total circumference. So my whole theory fails. That's a great way of phrasing it scientifically. What would cause me to not believe in my theory here about the percent of the circumference being represented? If this does not compute, when I take 1.570 divided by 6.283, if it doesn't come out to exactly 25%, or since we're only approximating pi out to these significant digits here, if it doesn't come out to really darn close to 25%, then I'm done. I'm finished. Stop the video. Change tapes. Find another YouTube channel to listen to. Because then I'm absolutely wrong and I don't know what I'm doing. But let's try it out. What I'm looking for here, ladies and gentlemen, is 25%. That would be the portion of the circumference represented by this bit of string from here all the way up around the arc to here. So let's do it. Moment of truth. Dun, dun, dun. 1.570 divided by 6.283. Ready? 24.9888%. If I'm rounding up, do you see? I've got 24.988%. That is really close to 25%. So I'll write 25%. If I wanted to stick with this 2 significant digits approach, I could come over here and call this 17%. Come over here and call this 13%. And come over here and call this 8%. If I was going to just cut off the decimal and round up, okay, 25%. I hope that because pi is being approximated, I'm not getting exactly 25%. It's really, 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 really close to within a 10,000th of a decimal point to 25%. I'm getting 25% to within, it's like 25% plus or minus 1/10,000th kind of thing. So that's because we're approximating pi, that's why we got 0.2499988 and not just 0.25, because I'm only approximating pi. But I hope that confirmed it for you there. 1.57 as a distance measurement of the circumference represents 25% of the total circumference. Okay, so if I were to continue over here, if someone asked you, what portion of the total circumference of the circle is represented by 120 degrees? Well, when someone asks you what portion of the circumference is represented by a circle at 120 degrees, what you should be thinking is, okay, that's a distance measurement from here all the way to here. What percent of the total circumference is represented here at 120 degrees? Well, we did 2 times pi divided by 3 gave us 2.094. What we do is we divide 2.094 by the total circumference of 6.283, 6.283, and what we get is the percent of the total circumference represented by the by this bit of string. 2.094 divided by 6.283. That gives me 33 1/3%. Okay, 33.3%. So this one measured out to 25%. So now I'm saying that this bit of string represents 33%. You know, this bit of string represented 1/4 of the total circumference. This bit of string, it's claiming, represents 33%, 33.3% of the total circumference, so like 1/3 of the total circumference. You know, if my distance here is, if I cut a bit of string here, I should be able to create 2 more pieces of string of that length, and if I laid them out, I would have 3 of those pieces would equal the total circumference. I'm hammering this point home because I want you to remember that radian is a piece of the circumference. If I had a pizza that I cut into 4 pieces, the piece of the circumference represented by the crust from here to here would be 1/4. The distance from one edge of the crust all the way around that big slice of pizza there. If I had a pizza that I cut into 3 equal pieces, the distance of the circumference around that slice, that enormous slice, which actually sounds delicious, would be 1/3 of the pizza, 33.3%. All right, let's just continue. At 135 degrees, what percent of the total circumference of the circle is represented by 135 degrees, or this radian measurement of 2.356? 6.283. So 2.356 divided by 6.283. 2.356 divided by 6.283. That equals 37.5%. 37.5%. At 135 degrees, I've got 37.5% of the pizza. At 150 degrees, what percent of the circumference of the circle is represented by 150 degrees, or this circumference portion that we're calling 2.617. Well, the total circumference of the circle is 6.283, 2 pi r. So we'll divide by the total circumference here, 6.283. Let's see what percent I get. 2.617 divided by 6.283. That's giving me 41.7% of the circumference. 41.7%. Let's jump down here to pi. Here's another crucial moment of truth. What portion of the total circumference of this circle of radius pi is represented by 180 degrees? Well, 2 pi r. So this better represent a half, because that's half of the circle. Visually, if I'm going around this line, I'm halfway the distance to the end. So this better darn well be a half. Okay, so we divide by 6.283. I'm sorry, I need to write 3.14159 divided by 6.283. Remember, we're just approximating here, but it better be darn close to some thousandth or 10,000th or 100,000th of a percent of 50%. Bingo. There. Out to several significant digits, it's 50%. Okay, there's no surprise here. I know some people are probably thinking, is this supposed to be a surprise? Well, I think it is, because if you have never thought about radians as a percent, then perhaps this is a surprise. 50%. So rather than computing all of the remaining portions or degrees, you see what I'm doing. You can do this. Let's just compute 270, because this is if this was 1/4 of the pizza, to think about a pizza, this is 1/4 of the pizza. This is half of the pizza. So that's got to be 3/4 of the pizza, right? 270 degrees had a radian measurement of 4.712. I'm really just trying to give some context to kind of like a decimal that's just sitting out there. It's just hanging out there. So we take 4.712 divided by 6.283. What percent of the total circumference have I got here from, if I start here and go and stop there, what percent? Well, let me tell you, ladies and gentlemen, brothers and sisters, it better be 75%, because that's 3/4, 3/4. Let's do the math. 4.712 divided by 6.283. Again, our approximation pi gives us to within a 10,000th 75%, just 74.996. So I'm absolutely at 75% right there. And then finally, over here, we already calculated this one. This is 100% of the circumference of the pizza, represented by radian 6.283. Now, I hope this has given you some additional context to understand just what is being asked of you, ladies and gentlemen, when you are asked to compute a radian. You're computing a distance. .3%. Let me put it another way. Let me shut off my alarm. The percent of the total circumference represented here at 30 degrees with a radian measurement of 0.52359 divided by the total circumference. This is a piece of the circumference. What piece? How much of a piece of the total circumference? Well, you got to divide by the total circumference. That would be 8.33%. I hope that was helpful. Thank you very much for watching. We'll do more fun things with this in a future video. Have a great day.